Ladies and gentlemen, we are going to start the first session. Please allow me to read the explanation of the first session. It's entitled Characteristics of Kyoto University WENDI. In April 2018, WENDI was established to promote multidisciplinary and holistic approach to research implementation, knowledge transfer, and capacity building in the fields of water, energy, and disaster management, as well as to foster linkages to other sectors such as food, biodiversity, climate change, and data science. WENDI aims at developing a comprehensive and transdisciplinary higher education and research for sustainable development (HESD) program for university students specific to Kyoto University, a KU model of HESD. In order to do so, WENDI will foster unique international collaborative research using existing UNESCO sites, including geoparks, biosphere reserves, and cultural, natural, and mixed World Heritage sites, in addition to Kyoto University's extensive field sites. In and out of Japan, bringing together 9 Kyoto University scholars in relevant fields as co-chairs, WENDI will act as a focal point for new endeavors in education and research. This session will reveal objectives and action plans proposed by the co-chairs, addressing issues that WENDI is concerned with. So I'm going to pass the microphone to Professor Tachikawa. Thank you.
Thank you very much, Dr. Yoshikawa. I'm one of co-chairs of the UNESCO chairs WENDI. My name is Yasuto Tachikawa, Graduate School of Engineering at Kyoto University. I'd like to talk about higher education and research for water-related disaster management in WENDI. So this graph shows the annual damage amount caused by water-related disasters in Japan from 1977 to 2016, about 40 years. So this graph is compiled by Emrit in 2007, and I used the latest water-related disaster statistics just published this spring, and this graph shows that, so this is 1977 and 2016, and this blue graph shows inundated area in building land. So you can see that, so this area is gradually decreasing and now almost stable. So this is due to many flood project works, and very successfully inundated area is reducing. But unfortunately, this bar graph shows the general property damage. So this graph doesn't change so much. And then this orange graph shows that general property damage per inundated area. You can see that this general property damage doesn't change so much, but inundated area gradually decreasing. So that's why the general property damage per inundated area gradually increasing, and also very high value and almost stable. And this graph does not include last year's Hokkaido disasters or northern Kyushu disasters. That value doesn't include. And of course, the last 2 weeks ago, we experienced very severe disasters in the southern part of the Japan. That value is also not included. So if we include the general damage for these disasters, I'm very much anxious that these values are gradually increasing and increasing. So the situation in Japan is not so good. Maybe much more, maybe water-related disaster maybe happened. One of the reasons is magnitude and frequency of water-related hazard increase. So this is compiled by Emrit, annual number of events that exceed 15 millimeter per hour, gradually short-time rainfall intensity increase without doubt. So this is not prediction, this is observed data. And so this is, and unfortunately, not fortunately, or this is a change of the populations. the 2 weeks ago, many people unfortunately lost their lives, and elder people are very severe situation. And you can see that in Japan, gradually population is decreasing, but the ratio of elder people more than 65 increase. So this is very, we need to think about that, how to avoid the very big disaster. So a systematic and interdisciplinary education and research is very crucial to mitigate the damage caused by water-related disasters. So one of the very important, of course, atmospheric science and also hydrologic science. So this is a prediction of future climate, and now very big typhoon hit the Japanese area. To understand how to make these kind of simulation, how to make a future prediction is very important, the topics we need to learn. And hydraulic and hydrologic engineering is of course important. So this is one of the simulation results that by giving the rainfall data into distributed rainfall runoff model and predict the river discharge. And not only hydrologic prediction and atmospheric predictions, probabilistic evaluation of economic damage due to water-related disaster is also important. For example, this is economic damage, and this Y graph shows exceedance probability. So this means that very rare case, gradually this economic damage also increase. So these kinds of economic evaluation is also very important. We need to study. Other science and engineering issues include, for example, real-time prediction is of course important, including data simulations. Dam reservoir management, this is very important. And these include statistical science, and maybe we need to treat big data, including remotely sensed data or very huge amounts of data. And not only atmospheric science and hydrologic science and engineering issues, planning, including land use regulation, or social science for information dissemination, disaster recovery, disaster mitigation policy. This is also very important. So, and not only this, adding this assessment of climate change impact is also very important issue. So there are many things to study, very lot. So the WENDI organizes a well-designed interdisciplinary course including lectures, exercise, field experiments, and intensive short lectures provided by different graduate schools at Kyoto University. WENDI offers a unique opportunity for systematic and interdisciplinary education and research to mitigate the damage caused by water-related disasters. Thank you very much.